Good afternoon, everyone. Welcome back. Thank you for joining us in a timely fashion. We've got a lot to cover this afternoon, so we're looking forward to getting into it. Our next session is entitled UTM/ATM Transitions from a traditional perspective. Although I don't see that everyone here is a traditionalist on this stage, so I'm interested in how that perspective will be crafted. It will showcase an opportunity, it will be an opportunity to showcase selected RFI submissions that describe the challenges and critical issues encountered when aircraft, manned or unmanned, transition between a UTM and an ATM environment. We have two moderators for this session. Before I go into that, I forgot to tell you a very important housekeeping item. That is that if you were here for the RPAS 3, all of those materials are now uploaded into the web at the ICAO website and available through the app, PowerPoints, and even the videos. We are going through the same exercise at Drone Enable. So you're going to have, after you leave here, access to all of the material that you're being presented today and the conversations. So you are part of the presentation. So don't hesitate to get those questions in on the app, on Slido, and also to participate in the dialogue with panelists here. And we have two panelists who can facilitate that very well, or two moderators who can facilitate that very well, and have done so famously in the past. Dr. Liu Hao is the director of the Institute of Aviation Law and Standards, a deputy director at the National Research Center of Air Traffic Management Law and Standards in China, and he's also an active member of the ICAO RPAS panel. He'll be joined by Mr. Peter von Blyenburgh. He's the founder and president of UVS International. He has been involved with unmanned systems since 1987. It's almost as long as I've been in aviation, Peter. He's a regular speaker at international conferences too, so like many of you that are listed here. Thank you, Peter. Gentlemen, the floor is yours. Have a great afternoon.
Thank you, Steve. As you've probably understood, I'm the granddaddy of all of this. I'm probably older than anybody in this room. There's the only one that is in the same league. We have a very interesting panel here. This is industry. Well, these guys are going to try and sell us something. We all know they haven't got the right bricks. They have parts of the bricks. Now, what is going to be very interesting is that we have a whole bunch of complementary bricks here, and we're going to try and find out which of these we can actually use, and we're going to find out which of them understand what UTM is, what ATM is, what ATC is. Our first speaker this morning is Markus Klopf. He is Director of Strategic Marketing ATM at Frequentis in Austria. Frequentis is a leading global provider in the ATM sector and also works on control center solutions in defense, public safety, public transport, and maritime. Markus has more than 20 years of experience in the telecom and ATM industry and is involved in Caesar and NextGen. He has led the drone and swim innovation cells at Frequentis. Now, the presentation that he is going to give will address two distinct solutions in the UTM-ATM domain. Creating a safe and secure connection point of ATM with UTMs, with an S at the end, plural, into a swim-based data sharing platform. And fast and efficient special operations approval in protected airspace with full integration and electronic flight strips at the tower, with a focus on controlled and protected airspace. Markus, enlighten us.
Good afternoon. I'm Peter. Thank you for this kind introduction. As I said, I'm Markus Klopf, working with Frequentis from Austria, and a few words on Frequentis first. Maybe that's the reason why we're on this traditional panel. So Frequentis is an established ATM systems provider. We are working in the ATM sector since a couple of decades already, and this has always been our main focus and main business area. But we now see things moving on also in the UTM side. I would like to, before we go into the solutions that he introduced so well, there are a lot of keywords and a lot of things, I would like to give you a short example on what happened to me and my team when we're doing some movie shooting, filming exercise for a remote tower movie that we did. So what happened there is we said, okay, we want to film some nice camera setups, some nice remote tower cameras at the airfield, at an airport. So that, as you can assume, turned out to be a very complicated process. It took about 4 weeks of paperwork before the thing happened. We had to fix the date when the shooting had to take place. This was really complicated. It turned out well at the end, fortunately. When we had this day of shooting film shooting with this drone, the biggest problem that we found out was that the drone operator was flying, but he had no communication with the air traffic controllers, nothing at all. ATC in the tower there, they were observing, they were giving the permission, but it happens to be that there is no cell phone communication allowed in this tower. So we had to find a manual way to communicate with the drone operator. And you can all imagine that this process is everything but really safe and can react quickly to certain incidents. So this is something which is really problematic issue, and that was really a good exercise also for us and a learning exercise on the things that I would like to present right now. I want to focus here on the controlled or protected airspace part. I will not put the uncontrolled airspace and UTM part into the focus of my speech. There are two things that are relevant and essential for this purpose. Number one is the UAV cloud data platform, and number two is the special operations approval, where the drone operator directly integrates with the ATC system. You heard it already a couple of times yesterday, and also talking to my other panelists here and colleagues yesterday at dinner. I think we all agree that this part of data exchange of ATM and UTM is necessary. We don't say that the UTM and the ATM has to immerse and be one part. I think this is yet too early, but I think the convergence part and the step-by-step convergence that was also presented in the introduction session here, this is something essential. For us, as a traditional company, traditional panel, don't forget this, we have already a product for this. We have a SWIM-based data sharing platform that exchanges data with all kinds of airspace users. So aeronautical information, flight plans, weather information, voice, everything is part of that data exchange. ICAO, Eurocontrol, and the FAA, they all pushed forward the standardization on these data exchange models there and service models. So this is something which is established. So how does this connect now to the UTM part? There is a need for a UTM open interface, for a bridge that connects the different UTM service providers. And I really mean service providers, because we will see multiple UTM providers operating maybe in the same airspace or maybe next to each other, and they all have a need to share information and also to interconnect. They also have a need to interconnect with other stakeholders that need that information. Just take fire brigade as an example, or police, ATC we mentioned already. Also the military organization, they all would like to have this common operating picture and this total picture of both UTM and ATM operations, because at the end, it's one airspace. The number 2 solution that I would like to bring forward here is the UTM integration at aerodromes, something that really was essential here at this drone filming that we took out, but this is also what we are pushing forward here. I would like to give an example here, and I think this goes on here as a movie. This is not a concept, this is a ready product that can be fielded. Here we developed this with our partner Altitude Angel, and you see there our Guardian UTM application where it comes to the airspace rules definition. This is the number 1 step in this whole procedure. So somewhere there is a tool that defines the rules of the airspace and that defines, okay, what level of operations is allowed and with which risk classes and everything. It also, of course, ties into the information management solution, into the AIM solution of the NSP, and is part of that. In a step 2, the drone user gets ready to flying. He actually creates a flight request, which will end up at the end as a full ICAO Doc 444 compliant flight plan in the ATM system. So this conversion part is the step 2, which is necessary. In the step 3, assume we are now near an airport, an aerodrome, in this protected airspace. The drone operator can't just go there and fly alone, and without permission, he needs to involve ATC here. And this is happening fully automatically with this flight plan being processed as any other AFDN AMHS message and sent as a electronic flight strips to the ATC controller, from where the controller can then actually decide, does he accept or reject this drone operation. Here we are in the full ATM world, so there is no special tool that is fielded at the air traffic controller, so there is no need for putting additional hardware into the tower. This is actually tying into the existing systems. That's really the important part here. I heard a lot of concepts in the past where people think, okay, they put another display into the tower. If you know how a tower looks like, I think, and you know how air traffic controllers think, they are not really in favor of additional systems and additional interfaces usually. And from then on, of course, the air traffic controller can take the decision to accept and reject the flight plan. And what is then also part of the solution is a secure and safe voice integration from the ground control station, from the drone pilot, to the air traffic controller. Something that is not working with transmitters and receivers in the drone itself, because that would be too much weight in the drone. Something that is really routed on the ground. It's a kind of a virtual radio communication. That was part actually of my Drone Enable 1 talk and also a part of a white paper. Okay. I would like to click through that here a little bit more. So what were the results actually of that testing to speed the things up? Where we defined the concept actually throughout last year and said, okay, what are the different components and what were the things that we would like to focus on? And we actually focused on trying to solve 2 distinct problems. The number 1 problem is the availability of the surveillance information from the drone, so that the drone surveillance information is available as in the common operating picture, including all other airspace information, all other information. So it needs a tracker, it needs an air situation display with showing all that information here. And the number 2 problem that we were trying to solve, and what was putting forward, is this conversion of the flight requests. The UTM systems today are very innovative, very good, but usually they don't speak the normal ATM language. And that's the conversion part that is needed. And in our demonstration, we found that this conversion part worked really well. Our test setup included different locations from our offices in Germany, in Austria, but also involving the US offices. We had a couple of air traffic controllers there, a couple of drone pilots there, flying simulated flights in the area. Everything was, of course, in airspace where it's allowed to fly these kind of missions. We didn't do any BVLOS for that kind of test purposes because that we were not testing BVLOS. We were testing the concepts here of surveillance and also of this flight plan integration. The results were really interesting. As I said, no additional hardware is needed for the air traffic controller. We were able to use existing ATM infrastructure, and there was no impact on the ATFM and AMHS messaging. So how do we move on here? I think if you say, okay, what technical readiness is behind that, we used components which are commercial off the shelf, which are available, technical readiness level 9. We put them together in a way where the ConOps, the concept operations, and also the technicalities are not yet clear. So we were assuming it's going to be technical readiness level 6. So it's clear that this needs more research and more actions. And one of the important steps to bring that forward is the Gulf of Finland use-based demonstration, which is a very large scale demonstration as part of CESAR, which we handed in with a lot of partners for the European Commission, and we are waiting for an answer currently if this proposal is accepted by the European Commission. If so, then it's going to be really interesting because we're going to cover a lot of use cases which are relevant, which are interesting. I mean, it starts with standard parcel delivery use cases, but we also go into dense urban fleet operations. We take in police interruptions. How does this work? How does it work with search and rescue missions, BVLOS operations? So these things are really interesting and moving forward. So to conclude here, the last time when I was in Montreal at the Drone Enable 1, I asked ICAO or I asked the drone panel to maybe look more. I was maybe one of the few presenters who were already at UTM and ATM together in the Drone Enable 1. Most of the other speakers had really focused on UTM, but I asked ICAO and the organizers to maybe put the focus on UTM and ATM, and I'm delighted that they listened so closely because today it's everything about UTM and ATM. Going forward, I think for what can be done in the future is to really, for ICAO, also to bring up the coordination with the necessary panels, and I really mean specifically mean the information management panels and also the communications panels, because it's obvious that there is to be some connection of this part. I also would like to ask interested ANSPs to come to us and invite us to talk to us and find out what we could possibly do together. And a last thing, and I think that's maybe really interesting, I was also taking part in SWIM and system-wide information management research. And maybe some of you remember here in 2016, CESAR and the FAA, with support of ICAO, were carrying out so-called SWIM global demonstrations, also mini-global. And I think we are here in the UTM, ATM world, we are ready to go for such a demonstration as well. It's something that could be organized on a global scale with global participation, to not talk about concepts, but to talk about the reality on how these things are going to be implemented and demonstrate that. Thank you.
Okay, dear colleagues, for rules of our colleague who speak English, please get the devices ready. I will switch to the Chinese channel. 好，非常感谢我们第一位发言人给我们讲到了他们如何为我们这个提供安全可靠的这个 UTM 的通讯解决方案，而且呢，去帮助我们更好的对特定运行场景的这个运行的批准许可来加速这个流程。我想啊，在我们第二位发言人开始之前，我想讲一下，因为今天整个下午呢都是由 Peter 和我非传统的部分，我负责传统的部分。 好像还有一点不是那么的这个适合。当然，也可能 Peter 比我更淘气一些。我想有几点吧。第一，想提醒大家的是，为什么我们这几位发言人能够在台上发言？很重要的一个原因呢，是他参与了我们国际民航组织此前所发出的那个号召大家来去提供解决方案的活动。所以我想，我们下面还有很多的企业，也许明年你们也希望能够站在台上和他们一样发言。那一定要等国际民航组织发出来 RFI 的时候，一定要回复提交你的文件，才有可能获得这样的。
Given to you, is sent to you. You can submit your proposals so that you can have opportunities to speak here. Second, we talked a lot about RPAS and APAS. Today, we switched to drones. So it's U.S. Industry Symposium for today and tomorrow. So these 2 days are the showtime of our industry. Be it the speakers on the stage or the audience in the crowd, just relax a little bit. Because in the past 3 days, we talked about the regulatory framework. But in the next 2 days, we're going to speak about innovative and disruptive innovation and the solutions for this innovation. Just relax yourself a little bit so that you don't fall asleep during the process. Because when you're relaxed, you can learn more. Just go wild a little bit. Third, I asked some of you, not everyone has downloaded the app of ICAO for this symposium, but still some of you may have some questions. So my suggestion is, first, if you're ready, you write it on a piece of paper, and maybe just show us you have some questions. Our secretaries will collect the questions. And when we enter the Q&A session, if you have questions, you can raise your hands. Because during the past 3 days, I don't see anyone raising their hands. Because maybe after you listen to the speeches and presentations, you will have some more feedback for the speakers. That's 3 suggestions from myself. Our next speaker is from Thales. Thales is very experienced in the industry. It's a very famous company in the world. In the traditional air traffic control, management field, it has rich experiences. Now it's entering the UTM field. And our speaker, Brenden, joined Thales in 2014. Now let's see what is this speaker's perspective of how can we face the integration of UTM and ATM. And during the past 3 years, Brenden has been participating in the FAA, the National Defense Department, and NASA NASA project of the United States. So I believe that our speaker will have a lot to tell in terms of the experiences and lessons. Now let's welcome Brenden.
Thank you very much, and good afternoon, everyone. Thank you to ICAO for the opportunity to join my fellow panelists here today for a discussion on the many challenges and varying approaches to UAS traffic management. And I think there are some very exciting and encouraging discussions surrounding UTM. I think one component that's particularly exciting is how in exploring these varying approaches, we are introducing new airspace management concepts with higher levels of automation that traditional ATM systems will soon need to embrace in order to address the growing density and operational complexity. But conversely, as we set our sights on designing and building out a UTM system, we should also draw from the existing concepts that have safely governed the skies for decades to, as there are many lessons to learn from and leverage, particularly as we seek means for tangible progress integration in the near future. Now, when we speak about UAS traffic management, I find it is often referred to in the context as just very low altitude, uncontrolled airspace. But with the ever seemingly increasing number of UAS applications, you quickly see how dynamic and fluid the operating environment truly is. Just in that low altitude uncontrolled airspace, there'll be wide-ranging environments varying in operational complexity, traffic density, vehicle capabilities, rural to urban areas, and manned aviation. In addition to that, those same UAS will often have to also safely transition to and from controlled airspace in a way that both minimizes any additional burden on air traffic control while simultaneously not prohibiting those operations from taking place. In addition to all this, we also have to understand how surveillance, counter UAS capabilities, and so forth will be integrated into the larger UTM picture so that, for example, how we will identify and react to a non-cooperative UAS that will both minimize the risk and disruption to the surrounding operations of both manned and unmanned aviation alike. So we recognize all that the UAS operating environment really encompasses. The responsibility of any low-altitude airspace manager quickly expands beyond that, which facilitates only unmanned to unmanned operations. It's something that really needs to understand how to bring all of these pieces together. In examining how to approach this problem, I think there are some lessons we can initially draw from the existing rules of the road structure, as it covers a somewhat analogous range of environments from low density with limited structure to high. Naturally, as density and risk increases, so will the need for structure and control, which I'd say is more or less what we see in traditional ATC systems today. I grew up in a small town in the United States where there wasn't a single traffic light in the entire town, but due to the low traffic density, multiple cars could pull up to an intersection and easily negotiate who got to go when without any real disruption or risk being introduced to the greater system or to themselves. But now that I live in Washington, D.C., I'd be terrified to pull up to a busy intersection and rely on that same approach. I'd much rather those responsibilities, at least for the time being, be delegated to an independent third-party platform or that automated traffic light. Now, when autonomous operations reach a level of maturity where those kind of negotiations, in this case for driverless cars, can take place, maybe those that can happen even in the busiest intersections, but in the near to midterm, I imagine that both the general public and regulators would probably prefer some kind of structure in the sense of a traffic light to be there. So when we look towards building out a management system for low altitude airspace, we need to examine what near to midterm functions will require what structure and control, so we can more efficiently and readily increase the operations beyond what is generally allowed today. So I think this will really require industry to adopt an incremental, pragmatic, and feasible approach that leverages an iterative process. So at the moment, I would put forth that there's rather non-insignificant gap between where we are today, which generally allows for routine access to limited operations in certain airspace, to with the potential to obtain waivers to them, and expanded operations in segregated airspace in the construct of UAS test sites, to where it is we're looking to go, where a traffic management system will be highly autonomous, mainly self-governing, driven mainly by the operators themselves, in a decentralized manner to enable even high-density operations in urban environments. Now, this end-state vision might very well be the solution best suited long-term, but with existing and rapidly growing demand of applications requiring airspace management functions, we need to understand what can best serve as an intermediate solution to increase routine access to operations beyond what is generally allowed today. So drawing on existing and emerging concepts in traditional ATM, I think will be an integral resource for establishing this intermediate step. So to really expand operations to include things that include beyond visual line of sight, operations over people, operations and controlled airspace and so forth, and maybe most importantly, safely enable these multiple independent missions of varying levels of complexity to fly in the same airspace at the same time. So the intermediate solution that we are kind of proposing for consideration follows a more traditional airspace management model in the near to mid future, to provide an efficient path towards integration in the near term that leverages some of the high levels of automation we're seeing today emerge in traffic flow management systems around the world, and identify what initial services and functions need to be centralized and what can be delegated to, say, the UTM service suppliers, all while ensuring fair and equitable access to the airspace is really maintained for all users. In this intermediate solution that leverages a low-altitude airspace manager construct, or LAM for a lack of a better term, seeks to provide that initial structure where none currently exists to enable expanded operations in uncontrolled airspace and provide efficient, minimally intrusive means for operating in controlled. This low-altitude airspace manager will aim to centralize initially some of those safety-critical functions through a mainly fully automated platform that will aim to safely facilitate operations between both manned aviation and between those seeking to provide management and planning services to the UAS operators. Now, similar to the rules of the road example, the low density, low risk environments that is uncontrolled by traditional ATM should very much remain uncontrolled, given that the operator meets established minimum operational performance standards in respect to the mission that they're looking to fly. Those operating this space can voluntarily share their position to provide those within their vicinity knowledge of their location intent, but ultimately the responsibility in this space is going to fall on the operators themselves to maintain self-separation. Now, of course, as density and risk increases in this uncontrolled airspace, due to there being more operators of UAS, helicopters, general aviation, and someday maybe urban air mobility, would have a need to, again, provide a little bit more structure to that environment. In the intermediate stages, having this higher density airspace controlled by a low altitude airspace manager can provide and more readily enable this complex operating environment. This can apply some of those concepts and components from traditional ATM to low altitude by examining what services can be initially centralized, such as capacity management functions, including operation prioritization and airspace deconfliction, and apply a central data exchange model to ensure that a single validated situational awareness picture is being leveraged by all users. Now, finally, in the low-altitude ATM-controlled environment, it's important that manned aviation operations remain unchanged. UAS operators seeking to fly in this space should expect to file a trajectory-based mission through a low-altitude airspace manager in some capacity, so that they can receive automated authorization or denial from air traffic control. And in this context, this low-altitude airspace manager can also provide the means for the operator to transmit their position as needed and receive commands from ATC if and when required. Really, the objective in the low-altitude ATM-controlled airspace is, again, to minimize any additional burden that we're placing on air traffic control by communicating the information to them in a format they're already accustomed to. And taking a somewhat closer look at a centralized low-altitude airspace manager as an intermediate solution for integration, this can be delegated by an ANSP to either a public or private entity in order to provide a more simplified and streamlined means of information and data exchange across all the various stakeholders, including the ANSP themselves through a portal to the low-altitude airspace manager, the ANSP data services such as a registry, the UTM service suppliers that are providing those management and planning functions to the operators, and then any local public safety or ordinance that any given operation may impact. It will also seek to centralize some of those initial core data services, including weather, terrain, surveillance, geofencing and georeferencing, and QNH correction, to ensure, again, that all these stakeholders are operating based off the same airspace picture. Again, it will also aim to centralize initially some of those safety critical functions as operation prioritization and airspace deconfliction. Now, by centralizing those safety critical functions in the near to midterm in this intermediate structure, we'll kind of aim to enable a later handoff and transition to occur to those UTM service suppliers to allow for a more decentralized operator-driven approach once those airspace management responsibilities is proven out and validated that can happen in a decentralized, self-governing fashion. while simultaneously not sacrificing the economic and social value of those applications that require some management service in the near to midterm. So kind of in summary, the vision that we're putting forth through this low-altitude airspace manager is really intended to serve as one of the many stepping stones in evolving air traffic management system. Whether or not we are discussing low-altitude or very high-altitude operations, we really can't afford our long-term vision of these environments to be as ones of isolated systems. We really need to be working towards interoperability where the level of complexity and density we are seeking through seamless integration of manned and unmanned aviation can be achieved without compromising the safety of the existing airspace structure. Now, I think we are very much in the midst of technological breakthroughs of autonomous operations. And there's no doubt that this will be playing a critical role as we continue to seek to accommodate more and more unmanned systems into the airspace. But we also have to recognize that this is not something that's going to be happening overnight, and can't expect our view of an end-state solution to necessarily act as the starting point for integration, and therefore need to spend equal amount of time and energy on what can, in the near to midterm, address the operational needs of the system in order to address this evolving air traffic management environment. So I think that's kind of all I have for the moment, and look forward to future discussions.
Our next speaker is Joe Polastre. Read that, Polastre. He's head of product for Altiscope at A³ by Airbus. That is a really complicated name. In the US. Now, Altiscope is the UTM initiative within Airbus's Silicon Valley Innovation Center. Last week, Altiscope, together with A³ and Airbus, released the blueprint for for skies? The blueprint for the skies? Their vision, that's their vision for the safe integration of autonomous aircraft into the skies. We're going to hear more about that. If you would like to start, Joe, the floor is all yours.
Hello. So I am Joe Polastre, and I am from Altiscope, and it is a very confusing Russian doll kind of situation where we work for Airbus ultimately. We work on studying UTM architecture and understanding how can we build a UTM system that meets the needs of evolving and emerging aircraft. You may have heard of A³ because we do have an air taxi that we are actually in the process of certifying now called Vahana, and so that is a reality that we live in. And I've come to Airbus through actually working for the United States federal government, from working from a number of startups and working on the integration of user-centered design principles into how we build services. And so this approach to UTM is really thinking from the user needs perspective and going forward and thinking what are the user needs of the airspace versus what are the government needs and how do we address the users. Let's see if I can get this to work. Beautiful. So the big question that ICAO is asking, how does ATM and UTM coordinate? So the question that I have when I see this is, well, okay, great, what is a UTM? I think there's already been about 5 different definitions I've heard just today of UTM. And furthermore, what are all these UAS doing? What rules do they follow? What procedures are they using? And so it seemed a little bit to us like putting the cart before the horse to ask what the coordination was when you don't actually know what they're doing that needs coordination. So we thought we'd go back and look at what's going to be using the airspace, what do they need, and if we know what they need, then we can back into what are the rules and procedures, and then what coordination needs to occur. So this is the vision that we all have, an integrated airspace where there's package delivery to a residence. We have air taxis that are taking off, taking people to work and to school in the background. We have airliners that are departing and arriving at airports. And so this is really the view that we want to see, and it gets much more interesting when you look near an airport. And here we also have air taxis that we envision are going to be taking passengers to the airport, delivering large amounts of cargo. We have small UAS that'll be taking pictures and imagery, and we'll be doing last mile deliveries. And the question is, how do we find that safe integration of this airspace? So this seems like a far-fetched future, it's going to be a while before we get in an air taxi, but we actually don't think that that's the case. So this is a video from January of this year. This is the Vahana air taxi in its first flight. And so we've had a number of flights and a lot of development since then, and you are going to be able to fly in an air taxi in the near future. So how is this all going to work? Well, the reality is that autonomy is going to apply not just to small UAS, but is going to apply to everything. It's going to apply to commercial aircraft, it's going to apply to helicopters, it's going to apply to air taxis, and it's going to apply to drones. And that requires some holistic thinking. The good news about that, being part of Airbus, is we already operate in all of these spaces. You probably know us best from our A350, A380 aircraft, but we also operate helicopters. We operate an air taxi service today. You can actually go to VOOM flights in Sao Paulo or Mexico City and on demand request a ride in an air taxi from the airport. We operate drone deliveries in Singapore through our Skyways program. We also are building urban air mobility vehicles, and we have high altitude drones like Zephyr that cruises at 60,000 feet taking pictures at 30 knots. The thing that you might notice from this picture is there's a natural separation of all of these drones. So we don't expect that the package delivery drone at 300 feet is all of a sudden going to intercept Zephyr at 60,000 feet, but of course they do cross and interact at some points. So we started thinking about this, well, how could we bring all of these things together in a safe way? Because as we operate in all of these spaces, safety is the most important construct for us. So we came up with kind of a simple three-step plan. The goal was concrete and actionable today. So first, let's separate the traffic where it makes sense. Then let's coordinate where it's needed, and that's where the ATM-UTM coordination comes in. And third, let's handle exceptions. So things are going to happen that are off-nominal, and we need a way to deal with that safely. Now today we've heard a little bit earlier about things like Lance and the coordination there, and I would argue that that's actually not coordination, that's an information service. You're filing a flight plan, but there's no active management of a drone and an aircraft by an air traffic controller. So we still need to get to that point of coordination. All right, so first let's start off with separate where appropriate. So there's a lot of cases where there's really no reason for these aircraft to mix. They're operating at different speed, different durations, different flight levels. And so if we assume that separation is natural and the norm, then we can just look at how we can keep those aircraft safely apart in their normal operations. We have procedural separation today. This is not a new concept. We can separate aircraft in time. And so we see this all of the time, both with time and altitude, where east and westbound flights travel at different altitudes. IFR and VFR flights travel at different altitudes as well. We have approach procedures where an aircraft will wait until it's time in order to approach the airport. And we have lateral navigation procedures based on navigation performance that basically provide separation as you're moving through a flight plan. Now, all of this is designed for very high-speed, fixed-wing aircraft. So what happens when you have smaller speed and much more variable drones? Well, at Altiscope, we've actually built a fairly sophisticated simulator. What the simulator does is it has each of the UTM components there running as if they were real UTM services, and then it simulates the physical world characteristics and the vehicle performance so that we can make it as realistic as possible. And we said we can answer this with some data. So that's been our kind of mantra is, okay, if somebody proposes something, let's see what the data behind it says. And what we did is we simulated 4 different altitude bands to see how does separation by altitude actually play out. And what we found was that as you move from 1 altitude to 2 to 4 altitude bands, we get significantly less collisions. You would expect that. What was surprising, when you go from 1 to 4 altitude bands, you've essentially quadrupled the amount of airspace available. There's 4x the airspace. So you should get 75% better safety. And in fact, what we found is the collisions reduced by 91%. So this works pretty well when we don't have a lot of density. And this kind of falls along with that big sky theory. Well, what happens when we actually have a much higher density airspace that we need to control? And this is where we're introducing the concept of corridors. Again, this is not a new concept. VFR corridors have been in use in the United States for quite a while. They're used in Los Angeles, around the Grand Canyon, around New York. And basically, corridors are just volumes of space that are defined with specific procedures that apply to them. So you can imagine near an airport, we can define corridors that are completely separate from the approach and departure path of aircraft. And around cities, where we might have a dense flow of traffic, we can define corridors based on performance, direction of travel, and so forth. And then around warehouses or delivery areas, we can also define corridors now in a different shape, a different volume, for the entry and exit of these drones that are picking up and delivering packages. So these work pretty well as long as we have enough slots, so to speak, just like our current air traffic control system for each aircraft. But what happens when the density increases? So we took a look at just the city of Chengdu, since we're all here, and there's about 14 million people in the greater area. And we said, well, what if everybody used an air taxi once per year? That would mean that there would be over 3,000 flights during daylight hours flying above the city of Chengdu. That's a lot of flights. That's more than we often see. And so we looked at a couple of other points. Well, what if just 5% of the people used it once per week? That would be over 8,000 flights. And then finally, what if just 1% of the people used it twice a day to commute to and from work during their rush hour? That would be over 71,000 flights an hour, more aircraft than we generally see worldwide in the air. That's just one city. Imagine how this plays out city over city. There are just simply not enough pilots in the world to actually fly these missions, and so autonomy is really the only way forward to reach these kind of scales and adoption. And when you reach that kind of scale, it's clear that procedures alone cannot actually handle all of the traffic. So that's when we get to coordination and ATM-UTM coordination. And where is coordination typically needed? Well, maybe a helicopter taking off and landing, general aviation in low to medium altitudes, clearly operations around airports, and maybe it's Zephyr taking off from the desert in Arizona, climbing up to 60,000 feet. Well, today, these flights are governed by two types of flight rules, visual flight rules and instrument flight rules. And visual flight rules are typically aircraft that operate fairly independently. They use see and avoid, and they generally don't take advantage of air traffic control services. Whereas IFR aircraft file a flight plan, they must use the air traffic control services, and separation is provided by air traffic control. So the natural thing people propose is, well, then we'll just use VLOS and BVLOS as our next terminology. And it turns out, and it was brought up by Eurocontrol earlier, VLOS and BVLOS are not flight rules. They're just simply ways of observing what's going on. And that doesn't define, the separation standards and the lateral navigation performance and all of the other aspects that go into flight rules. So what we've done is come up with a proposal, and we're looking for your feedback on it and your insight. And we've called it Basic Flight Rules and Managed Flight Rules. And we've made it very similar to VFR and IFR. So in basic flight rules, you fly independently outside of controlled airspace, and you're responsible for your own separation. Whereas in managed flight rules, you file a flight plan with your UTM service provider. Your separation is managed by the UTM service provider, and you stay in contact with them during your flight. Now, the reason this is different than VLOS and BVLOS is, let me give you a couple examples. If I'm a hobby drone pilot, I can fly using basic flight rules, using VLOS to see and avoid other aircraft. But if I'm a sophisticated Vahana air taxi with LiDAR and sensors, I can also fly using basic flight rules independently and avoid other aircraft. So you can see we have two very different aircraft, two very different operations, can both fly under that paradigm. And the same is true for managed flight rules, where obviously a Vahana could be controlled and managed by a UTM service provider, but also if I'm there with my tablet flying my drone, I could get commands and trajectory adjustments from the UTM service provider as I'm flying under managed flight rules. So this is a bit of a shift in how we've been talking about VLOS and BVLOS, and it's something we're exploring more. So we use these flight plans to coordinate, and a typical aircraft will file a flight plan, and basically that will happen days or weeks in advance, and it'll automatically get activated as they're ready for departure. In contrast, a drone will file a flight plan, but we envision those flight plans to be much more detailed and have 4D timing information associated with them. So you're really filing an intent to fly, and then when you're ready to fly, we can activate that. So you would file that with your UTM service provider, and that would ultimately get stored in an information service provider, similar to what Brenden talked about with SWIM. So SWIM or an ANSP could provide that. When another drone comes along, it has its own flight plan, which it sends to its own UTM service provider, and they actually communicate with each other to deconflict that plan, reach some agreement, and then ultimately provide that through to air traffic management. So this whole thing allows us to now have coordination between the ATM and the UTMs and a path for that communication. So we ran a simulation of this as well, because we wanted to see what happens when you actually provide this aircraft and drone flight plan filing service. This is a video of 1,000 flights per hour over Tokyo. And so you can see this, even at a quarter of what we expect over Chengdu, it's quite a lot of flights that are flying. And what we find is actually we can, just by using this flight plan filing and deconfliction, we can improve safety by 5x while only decreasing the efficiency of the airspace by 1/2. We think that 1/2 will get much better as the algorithms and technology get better. So finally, handle exceptions. So you have a temporary flight restriction, maybe there's an emergency, and you need to get an aircraft in there, and we have drones and other aircraft operating at many altitudes in that area. How do we handle such a scenario? Well, we can do a very similar interaction where, as a helicopter, I contact air traffic control and I request priority clearance to depart. I depart, and during that time, air traffic control contacts the UTM manager, which then contacts the service providers, and they in turn contact their drones. A Vahana gets that message, it adjusts its trajectory, and thus is no longer in the way of the helicopter, whereas maybe a drone fails to respond. That information can be relayed back to air traffic control. Air traffic control provides instructions back to the helicopter, and the helicopter avoids that area and lands safely. So by putting in place this structure, we're able to enable these type of on-demand emergency applications. So what's needed? What do we have to do to make this all possible? We want to make this concrete and actionable now. Well, first is standards, and this is where organizations like ICAO come in. We learn from aviation incidents because we use the same standards worldwide, and we don't want to move backwards by having local standards such that incidents in one area are not things that we learn from in other areas. We need security. Our attack surfaces are going to explode exponentially based on the number of new distributed participants in the ATM-UTM system. And finally, we need an architecture we all agree on so that we know what are the roles and responsibilities and how do they communicate and coordinate with each other. Now, there's way too much to talk about right now, and Peter's already telling me I'm running out of time. So the good news is we've published all of this in the interest of being open and transparent and collaborative. So it's on utmblueprint.com, and this is a diagram of one of the UTM architectures that we propose. So it looks a little bit like this. And you can find a lot more in there, including how do we go from no automation to full automation. This is our roadmap for policymakers, regulators, technology providers, and service providers so that we can all work together as we need, dependent on the steps that each of us are participating in. So I encourage you to go download the blueprint, utmblueprint.com. We send out an email pretty regularly with our simulation results. And so you can go sign up for those emails if you're interested. And finally, to Peter's point about we're all up here to sell something, the good news is all of this is free and we're not selling anything unless you have a few $100 million and you want to buy an aircraft, then come talk to us. But otherwise, we're interested in you participating. Come talk to us at utmblueprint.com. Thank you.
Whatever, which one will be the first naughty boy?
Okay, all of this looks great to me. Where is all the money going to come from? Who's going to pay for all of this? Airbus says it's free. Yeah, this is free. But the next stage, and this goes for all three of you, who is going to buy the stuff that you're proposing or the services that you're going to propose?
They're all deferring to me. Okay. I mean, I think we all believe that there's a market that's going to be there, right? And currently air traffic management and ANSPs There's usually one participant in a region, and we believe by having multiple participants, we can lower costs and have competition, and that going to tens of thousands of air taxi flights in just a city in a day, that this will either pay for itself by the fact that we'll sell more services or we'll provide more aircraft or what have you. So we think that it's a long bet for sure, but we think that there's a marketplace there that is a competitive one that we can all participate in.
Okay, that's great. That's looking into the future. What do we do about the tens of thousands small and medium-sized companies who are operating today? What do you do for them?
I think they're in the next panel. I mean, Airbus has a venture fund. We invest in small to medium-sized companies as part of our long-term strategic objective. We are an operator in some regards, right? We do provide those services as well. So
maybe I can come in here from a medium-sized company point of view. I mean, we are not as big as Airbus, of course. We are a medium-sized company, and of course this needs to be a business for all of us, and also at the end it needs to be a marketplace where services that are provided are being paid for. This is the same in ATM, and also I think it will be the same in the UTM space. Right for now, I think it's important for organizations, research funds to direct research into the right area. And I say we are not doing ground-based basic research here. I think it's already in the applied research stage. I mean, we talked about the SSR very large-scale demonstrations. We heard it here. This is not concept, this is reality. And of course, this needs to be paid for. So I think it's also up for policymakers and research institutions and nations to fund these things to bring also small and medium companies into this, because the innovation clearly comes here from the small companies. That's what's our observation so far.
Yeah, as far as where the money comes from, at least in the near to intermediate stages, if I had the answer to that, I'd probably sell it and retire, because I don't think it's really a clear answer at the moment, and it's as a result, that's why we're kind of going in circles a little bit, trying to figure out how to actually move this ball, down the road a little bit. So I think in the early stages, it's going to require some to really just double down and invest and try to build out that infrastructure where some of that longer term visions that start to be enabled. But it's hard to say where the money comes from at this point. I don't personally have a good sense of that.
Have you got something?
Oh, yes, I have one question from my side. That is, now we're talking about what UTM is, what a UTM could provide, and we're also talking about the integrity of UTM and ATM. But since we have Frequentis, we have Thales, we have Airbus, you have so many years of experience in the traditional aviation. Have you ever think about it? Do we need a new traffic management system that is UTM? Can we think about we have a new version of ATM? So probably we call it a UTM version 2 or ATM Plus to resolve all the challenges brought by the US operation. Do we really need UTM? The question is open for all you three.
Yes. The answer is yes, and the reason is that you have to imagine that autonomy is going to take hold in all parts of aviation, and so there's no reason that jet aircraft can't fly under UTM-style rules and coordinate with a UTM system, and that may be, well, not maybe, it should be, we should design it to be even more resilient than the existing voice communication system that we have. So I think the answer is yes, and I think the question to ask is like, will air traffic management just become UTM, or as sort of the RFI proposes, is UTM the separate entity that must coordinate? I think that answer is still open, but we're exploring how could UTM also be what's used for all of aviation.
Yeah, from a Frequentis point of view, I mean, the answer is definitely yes as well. And actually, you had it also in your presentation in ATM 2.0, and I think this is something that's going to happen. It will be a future traffic management system. It might even converge more entities. God knows who. Maybe it also takes into account unmanned or autonomous cars at some point in time. I mean, maybe we can ask some futurist here that could deliver an answer on that question. ATM will definitely change, but we have seen the change in ATM takes some time. There is innovations happening in ATM a lot. It takes time. UTM is definitely one of a disruptive innovation that shakes ATM a lot, and it will change ATM as we know it today to a very large extent. I'm convinced about that.
And yes, I also agree with those points as well. As we're working towards a seamless integration between whether it be manned aviation or unmanned aviation, we really do have to be looking at interoperability and not be viewing any of these as their own isolated environments, because that would do us a very significant disservice and kind of shoot ourselves in the foot as we try to really expand upon kind of this vision that we're looking to achieve. So we're trying to create an environment where there's going to be package delivery with urban air mobility, kind of operating in the same space around the vicinity of airports. All of these systems are really going to have to speak to one another in a way that's going to be really have to leverage much higher levels of automation and then eventually autonomy once that technology matures to a level where it can be implemented in the airspace. But I definitely agree that we have to be working towards that kind of one airspace picture.
Okay, Peter, I will continue. Since we got all 3 yes, okay, you wanted to have a UTM, which means a new business opportunity. But tomorrow we will also have one panel which will be moderated by Nancy. We will also have a very high altitude operation. We will also have a commercial space transportation or suborbital transportation. Okay, probably some people will say, okay, since we have a UTM, we also need a STM. That means in the future we will have a ATM, UTM, STM. Now we're talking about an integration of ATM and a UTM. If we have 3, how we integrate these 3? When we are providing solutions for the US operation, we are also provide one good or bad example for the space transportation. When the solution is also bring some problem, do you still think that is your answer? Yes. You may change your mind, but this question will also continue to our second session. So for the untraditional part, if you change your mind, you may say, take the microphone to say, okay, I will change my mind. I want to give a little bit more different idea. But if you still keep your idea, but you want to give more idea to share, the floor is also open. Thank you.
Answer is still yes. With what you're proposing, it's really interesting use cases, and I think we have this opportunity. A number of people have also said this, so I can't claim that it's my original idea, that we need to design UTM more like the internet, with performance and layers rather than as a sort of fully monolithic system. And in doing so, then these new applications become possible. You could have a corridor over a space launch site. There's nothing that prevents that. And it says in order to participate in that corridor, you must travel above, Mach 6. Well, if your aircraft isn't capable of that, then you don't meet the requirements of the procedure and you're not allowed to operate in that area. So I think there's ways of creating constructs in sort of the new UTM world that allow a wide variety of things we haven't yet imagined and create a future-proof system so that as all kinds of different things in aviation, maybe jetpacks become the norm, I don't know, but we should allow it. It should be something that should fit into the system without having to create new regulations. So let's do this once and then let everybody participate in it, going forward based on their performance.
Peter, you have more questions or, okay, please.
Yeah, I will stick to my yes. But I attended a conference, I think it was last year, from ICAO and UNOSA, the UN Space Agency, where they also brought up the space traffic management discussion in that conference. And it was very clear that from a technical point of view, this is going to happen and that is going to converge. If it's a separate space traffic management system, I don't know. But interestingly, there are things coming in from a liability perspective, from a law perspective, policy. There is air law and there is space law, and I learned that they are very different. I'm not a legal expert myself, but I learned they're really very different. And these are things that needs to be taken into account here. But I think as we are building control rooms for all kinds of areas, as before said. I mean, we're doing maritime, public safety, public transport, and I can really imagine a control room that takes care about both air traffic, UAV traffic, and also space traffic. I think that might be something that we see in the future.
Okay, thank you all for our panelists. Peter, we are running out of our time, so probably we don't have any opportunity to invite our colleagues to raise questions in this room. I would like to invite Peter to have a quick wrap up for this session, and then we move to the coffee break. Peter.
Okay, thank you very much. This is really difficult to wrap up something like this by somebody who is not technical like me. What I take away from all of this is that, yes, it's already started. Yes, we have industry dynamically involved. We have industry with vision. That's also very interesting and necessary. The one question that I had that I didn't throw out because we didn't have time was if the three industry representatives sitting here could express one wish to their National Aviation Authority relative to advancing what they're doing, what they're developing, what would that be? We still have a long way to go. We have a long road to go. But like has been said earlier today, we can only do this if we collaborate, if we put our ideas on the table, and if we permit the community to take what is best and then go forward. None of us can do it alone, and nobody has the right solution. But thank you for putting your solutions on the table. Let me stop there. You want to finish? Okay, thank you very much. We'll now stop for coffee. You're going to announce it.
So I think you might have wanted to skip the coffee so that we could have done another 10 or 15 minutes of that. But we're not going to take away from the rest of the program, which runs quite long this evening. So 3:30, we need to be back in the room to begin the next panel session. But I want to thank our panelists and our two moderators for a very engaging panel. Thank you all very much.